We previously discussed the definition of a marginal probability, which was simply the probability of a single event with no consideration of any other events occurring. In this video, we'll discuss a conditional probability, or the probability that an event occurs given that another event has occurred. If A and B are two events, the conditional probability of A given B is the P of A given B. That is, given that we know that B has occurred, what is the probability that A will occur? For example, what is the probability of system failure in the next year given that it didn't fail up till now? Not witnessing a failure previously may affect the probability that failure occurs this year, and such a probability would be described with a conditional probability. The probability of a system failure in general may be different than the probability of a failure if we haven't seen a failure before. For another example, if we define event A as it rains today, we could describe the likelihood of A with P of A. If we define event B as it rained yesterday, the conditional probability of it rains today, given that it rained yesterday, is P of A given B. That is, given that we have information that it rained yesterday, that may change how we characterize the probability that it rains today. We might be improving our ability to characterize the probability of A, given that we know that B has occurred. If events A and B are independent, then the probability of A given B is just equal to probability of A. That is, if A and B have no influence on each other, then knowing that B has occurred doesn't change the probability that A occurs. For example, say that event A is defined as system failure in the next year, and event B is defined as your cousin had her tonsils removed at age 5. Odds are good that your cousin's tonsils don't affect the performance of the system. Those events are independent of each other. The probability of A given B is equal to the probability of A, and the probability of B given A is equal to the probability of B. The complement also applies here. The probability of A complement given B is equal to 1 minus the probability of A given B. That is, given that B occurs, A and A complement make up the entirety of possible events. So the probability of A given B plus the probability of A complement given B is 1. Note that we can take the complement of the primary event that we're interested in, not the conditional event. That is, it's not true to say the probability of A given B complement is equal to 1 minus the probability of A given B. We'll keep exploring probability rules in later videos, and we'll find out how to actually calculate the probability of conditional events.